Okay, now we're on our second objective, add and subtract mixed numbers. There are two different methods that we can use to solve this. So instead of putting steps for each one, I'm going to show you both of them. Okay, so we'll start with A. We'll rewrite the problem. 3 1/2 plus 1 3/4. First thing again you'll notice is our fractions don't have common denominators. Okay, so we need to make our fraction parts have common denominators. Well, we should know how to do that by now, so I'm going to kind of go a little quick through this part. So 3 1/2. I need to know 1/2 and 3/4. What denominator would they have that be in common? Well, that's going to be fourths. Okay? I'm going to have 3 in some number of fourths, and then 1 in some number of fourths. Okay? Well, 1/2 is the same as 2/4. 3/4 doesn't change. It's still 3/4. Okay? So we got common denominators, so now we can add these. One method that you can do is to add the big numbers and then add the fractions. Okay? And then simplify it. Well, if I take 3 plus 1, that's 4. And then if I take 2/4 plus 3/4, add the numerators. 2 plus 3 is 5. And the bottom is in fourths. Okay? Now we can't leave 4 and 5/4 because it looks way too funny. So let's stop and think about this. 4 and 5/4 is the same as 4 plus, and then we can change 5/4 into 4/4 plus 1/4. Okay? Because 4/4 plus 1/4 is 5/4. Now let's think about why we would want to do that. Because this number, when I got the same number on the top and the bottom, 4 over 4, that's the same as 1 whole. So really this is 4 plus 1 plus 1/4. Okay? Well, I can add 4 plus 1, that's 5. And then I've got plus 1/4. And 5 plus 1/4 is just 5 and 1/4. Okay, so that's method 1. You can add the big numbers, and then add the fractions, and then simplify it. Okay, if possible. So that's one possible method. Let's look at another one with the same problem. So we're going to scroll way down here. So let's see the problem again. 3 1/2 plus 1 3/4. Okay, so 3 1/2 plus 1 3/4 again. Option 2 is to take each one of these and change them to a fraction that has just a top and a bottom. Okay, and the way that we change them is by using the wheel method. We talked about this before. Okay, or times plus, where you take the denominator times the side number and add the top one. So 2 times 3 is 6, plus 1 is 7. That's my new top number, and our bottom number stays the same. So 3 1/2 is the same as 7/2. Now I can do the same thing for 1 3/4. Take 4 times 1 plus 3. Okay, well 4 times 1 is 4, plus 3 is 7, and then I keep my bottom number the same, so 7/4. Whoops, not 7/7. We don't want 7/7, we want 7/4. Okay, now we can add these. They're just like the ones we did in the very first example. Okay, so, in the second example. They don't have common denominators, so first we have to make common denominators, and that's going to be fourths again. Okay, well, to get from halves to fourths, we multiply times 2, because 2 times 2 is 4. So we have to take 7 times 2, and that gives me 14. Over here, the bottom number stayed the same, so the top number has to stay the same. Okay, now we can just add these like we did before. 14 plus 7 is 21. Oops, let's erase that. Hate when it does that. 14 plus 7 is 21. Keep the bottom number. Now again, this number right here, 21/4, is simplified. There's nothing that goes into 21 and 4, so the only other thing we can do is to change it to a mixed number. And to do that, we take the top, divide it by the bottom. 4 goes into 21 5 times. And then we've got our big number is the 5, our numerator is the 1, and our denominator is the 4. Okay, so if I scroll back up here, two different ways to solve the same problem. Okay, it doesn't make any bit of difference which way you pick. If you pick this method down here, or the method I showed you up top, which is going to run in here, so I'll move it a little bit, or that method, where you take the big numbers, or the whole numbers, and add them together, then add the fractions together, and then change everything. Okay, it's up to you. Whichever method you choose is fine with me. Okay, just make sure you show your work. So now let's do another example here. To do the other example, I'm going to have to erase this stuff down at the bottom, so if you don't have it, go ahead and pause it. Okay. So we'll go ahead and erase this stuff so it goes all the way. So we got room to write some more. And sorry, this takes a little bit here. So while I'm talking again, or while I'm erasing things, it does not matter which method you use. You're not going to bother Mr. Ayers whichever way you pick. Okay, so let's solve B the same way here. Okay, we got 3½ minus 1 3/4. Okay, well, I like to set these ones up like a regular subtraction problem. Okay, so I'm going to go ahead and erase this and write it as 1 3/4. Now, first thing again we need is common denominators. So 3½ is the same as 3 2/4 minus 1 3/4. Okay, so now I've got common denominators. Well, if I subtract these, I've got to do this like a regular subtraction problem, okay, where I start over on this side. So 2/4 minus 3/4, I cannot do that. Okay, I have to borrow from this. So I'm going to borrow and make that a 2. Now think about this. I borrowed 1 whole. Okay, so we have to think about how many whole, or how many fourths are 1 whole. Okay, because I'm taking 1 whole away. So really, I'm taking away 1 whole, or 4/4. Okay, well, I had 2/4 here, and I'm taking away 4/4. Okay, because I took 1 away from here, so I'm taking away 4/4 plus the 2/4 I already had. That's going to give me now 6/4. Okay, now I can subtract these. 6 minus 3 is 3 for the numerator, and my bottom number when I subtract fractions always stays the same. And then 2 minus 1 is 1. 1 3/4. That is simplified. Okay? And it's one way to solve this problem. The only thing I'll caution you on is the borrowing part. Okay, we've got to understand that when I borrow, I take away 1 whole, which is in this case the same as 4/4 because of my bottom number. Okay, so that's where this becomes a little tricky. If you don't like that method, we can do another method just like the bottom we did the first time. So we'll rewrite the problem again. 3½ minus 1 3/4. First thing we need to do is change these to just fractions with a top and a bottom, where we do times plus. Well, 2 times 3 is 6, plus 1 is 7, gives me 7/2. Minus, then over here, 4 times 1 is 4, plus 3 is 7/4. And again, I cannot add and subtract fractions without common denominators, so make sure we show work on this. We're going to make common denominators here, so 7/2 is the same as, and our common denominator is going to be fourths. Okay, well, 2 times 2 is 4, so 7 times 2 is 14, so this changes to 14/4 minus 7/4. Now we can subtract these. 14 minus 7 is 7, and the fourths stay the same. Again, this answer right here is simplified. Okay, there's nothing that goes into 7 and 4, so we can leave it like that, that's fine. Or we can take 7 divided by 4, and we're going to get 1 3/4. Okay, either one of those two answers. Now I forgot to say this before when I was doing these kind. You don't have to have both of these answers. You need to have this one up here or this one down here. Okay, they're the exact same number, just written different ways. Okay, let's go on to our last two examples. Okay, this example says the end of a 2x4 piece of lumber is actually about 1.5 by 3 inches, or 3.5 inches, so it's smaller than what they tell you. They want to know if one is nailed on top of the other, what are the combined dimensions of the end? Okay, well, we've got two different ones of these nailed together. So we need to think about how big is each part. Well, each part is 1.5 inches. Okay, because it's this part right here. So we're taking 1.5 inches and 1.5 inches and combining it. That means we're adding them together. 1.5 inches plus 1.5 inches. Okay, you can do whichever method you want to solve this. I'm going to use the one where we add the big numbers first. Okay, right here, 1 plus 1 is 2. And then our fractions, 1/2 plus 1/2 is 2/2. Okay, well, that's the same thing as 2 plus 1, because 2/2 is 1 and 2 plus 1 is 3. So we got 3, then we need to make sure we label this inches. Okay, so we took the 2x4s that were actually 1.5 by 3.5 inches, stacked them on top of each other, and we added those sides together and got 3 inches total. Let's go to another last example. Okay, the carpenter cut 15.5 inches from a 2x4 that was 92 5/8 inches long. How long was the resulting 2x4? So here's our big piece of lumber, and it is 92 5/8 inches long. Okay, and off the end of that we are cutting 15.5 inches. I want to know how much is this piece right here. Okay, how big is that? Well, we need to take the whole entire thing that we had, 92 5/8, and subtract our 15.5. Okay? Well, first thing we need again is common denominators. So I'm going to have 92 5/8 minus 15, and then 1/2 is going to be how many eighths? Okay, because we know eighths are our common denominator, so 1/2 is equal to 4/8. Now I'm just going to subtract these. Okay, again, start on the right just to make sure we don't have to borrow. Well, my top number here is bigger than the bottom one, so I can go ahead and subtract those. 5 minus 4 is 1, and I keep the bottom number the same because it's eighths. And then 92 minus 15 I borrow here, and that should be 77. Okay, so I got 77 1/8, and again my label was inches. So 77 1/8 inches long. Okay? Alright, you got any questions? Let me know. Otherwise, happy homeworking.